Good morning, everyone. This week's topic for calculus is 4.6 rectilinear motion. The first day, I would strongly recommend for you guys to read page 288 through 293 and look at the pictures and diagrams and sample problems. The big concept here is the relationship between the position, velocity, and acceleration curve. The AP test writers call the position function x of t. Our textbook calls it s of t, or just s, and that's the position. One derivative away from the position is the velocity. So if you take the derivative of the position, you'll get the velocity, and here are the different notations for that. The velocity function is called v of t, or you can take the derivative of s with respect to t and get ds dt, or the velocity. That not only tells you how fast you're going, it tells you the direction that you're going. If velocity is positive, it's moving right. If it's negative, you're moving left. If you're throwing an object up, that will have a positive velocity. As it falls to the ground, that's negative velocity. So up is positive and down is negative. The acceleration is one derivative away from the velocity, or two derivatives away from the position function. Here's the notations for those. Again, one derivative away from the velocity is the acceleration, or two derivatives away from the position is the acceleration. They threw another variable in here called speed. Speed does not give you the direction that you're going. Speed is always positive. Speed's the absolute value of velocity. The other concept in this section is determining whether a particle is speeding up or slowing down. And a particle is said to be speeding up when both the velocity and acceleration have the same sign. That means if they're both positive, then it's speeding up. And if they're both negative, that means it's speeding up, but to the left. A particle is said to be slowing down when the velocity and acceleration have opposite signs. One of them could be positive, one of them could be negative. That would be an indicator that they are slowing down. The next portion is to determine the nature of the velocity and acceleration. Figure out if the velocity is positive or negative, and do the same for the acceleration. And then once you know those two values, figure out if the particle is speeding up or slowing down. You have to be really careful at what graphs you're looking at here. In this graph, we're looking at a position versus time graph. So remember, one derivative away from the position is the velocity. So that is like the slope of the tangent line. If you put a little paper clip here or a little paper clip here, these things are the slope of the tangent line. That's the velocity. The slope of the position function is the velocity machine, and we see it's falling as you read it from left to right. So what's the nature of the velocity on this position versus time curve? That's right. Acceleration is two derivatives away. So where velocity is the slope of the tangent line testing machine, the acceleration is the concavity testing machine. So we're looking at, is this position function concave up and could hold water, or concave down and would spill water? On this position function, it's concave down. Since both velocity and acceleration have the same sign, this particle is said to be speeding up. I hope that makes sense. Let's take a look at another one. It's critical that you look at what type of curve it is. And again, this one is a position versus time curve. So the same rules apply. The velocity is just one derivative away from the position or the slope of the tangent line. Put a little paper clip on there, put a little paper clip. The slope of the tangent line is falling as you read it from left to right. No matter where you put it on the position versus time curve, the velocity is going to be negative. Acceleration is 2 derivatives away from the position curve. That means it's the concavity testing number line. This function would hold water. It is concave up, so the acceleration is positive. Since the velocity and acceleration have opposite signs, this particle is said to be slowing down. So far, so good. There's only so many ways that they can ask those questions. Okay, now let's take a look at the last 2 problems here. This is a velocity versus time curve. Since it's a velocity versus time curve, it is already up above the t-axis, and any y values that are up above the t-axis are said to be positive. The velocity's nature is up above the t-axis, so it's positive. No calculus required to find the nature of the velocity when they give you a velocity versus time curve. The next thing we need to test is for the acceleration. How many derivatives is the acceleration away from the velocity? Just 1. So the slope of the tangent of a velocity curve will give us the acceleration. And the slope of the tangent of this curve, it's rising as you read it from left to right. So the first derivative of the velocity is always positive. The first derivative of the velocity is the acceleration. This particle has a positive velocity and a positive acceleration, so we can say that this particle is speeding up. Last, again, this is a velocity versus time curve. The AP test writers like to sneak those things in on you. The velocity is the velocity. So we're just looking for the vertical values here. Since the velocity on this picture is strictly down below the t-axis, those velocity values are like the vertical values, like a y value would be, and they're all negative. No calculus to show that the vertical values of those are negative. The acceleration is 1 derivative away from the velocity. The acceleration is the first derivative test for velocity machines. And that first derivative test shows that it's falling as you read it from left to right. So the acceleration is negative. Since both velocity and acceleration are negative, this particle is said to be speeding up. I hope all that makes sense to you. Your homework assignment for Monday will be page 294, 1 through 5. Page 294, 1 through 5. I hope everything's going well for you. Stay healthy. If you have any questions, please just email me and I will post a response. Talk to you soon.